So welcome everyone to our Cyberops
part two.
Part two. Okay, so I'm going to share my screen here. And we're in the lab. I am going to pull this out and put it on this side over here and put this over here. And folks, I'm going to turn my video off so we won't have that in the way. Okay, Cyberops. Part two. All right, so step
Not
two.
this one.
Okay, editing, saving kit config file. So edit bash RC.
Why mine one is different than yours?
This is a, are you using the wrong document?
No, so far it is okay. All files.
Okay, so Cyberops.
Yes.
Okay.
This one, yes.
So file open.
Type a sentence.
Okay, got to do all files. So type all files. All right, so there's bash RC, and then click open. So there it is. Is that what you were not able to get done, or?
I did that part.
Okay, so it's 132, so you can just change it. Load it 32, place it at 31. So if I can get down here. Oops.
Part two.
Oh, part two. Okay, hold on. Part two.
Part two.
Well, that is step two. Okay,
no,
I'm on step
two.
Part two.
Number a B.
What page? I don't see a part two. Okay, there's part 2B. Nano. Okay.
Yes,
so,
this one.
Okay, so let's do no here. All right, so you go here.
Yeah.
You're going to create a file, nano.
Yes, that's one I did it.
Space.txt. And it's just nano.
Yes. Now, number B, I cannot do it. Home and end. When I click home and end, it is not going beginning and ending.
Okay, so
B, C, and D. I couldn't finish it.
Okay, let's do this. Let's do this. This is a test. And it's probably not, I get what's probably this is a test. All right, so home. Yeah, it's going to the front for me and end.
Are you using your keyboard?
Yeah.
In the keyboard, if you click the home, it is going to home?
Yep. Let me ask you this. Are you on a Mac?
No, I'm in Dell.
I'm on a Dell keyboard. And now let me ask you this. Okay. I'm still doing it now. Did you happen to get outside of here?
It's a laptop keyboard. It may have to be a function.
It may be. If it's a laptop keyboard, yeah. Is it a laptop keyboard?
Yes.
Then more than likely you got to hold down the function and the home or end, because it's not reading. Right. Yeah, I bet that's what it is. Good call, Nick. More than likely that's what it is.
Okay.
And one thing, if you find that's an issue, you could try to just take a regular keyboard and USB keyboard and plug it in and see if you could have it work also. But it should be like a function key. I don't have my laptop up here, but you probably on the Dell keyboard, you hit function and it would work. Okay.
That maybe that is the reason.
Yep, I bet that's it. Hey, Jerry. Yeah, I bet you about guarantee that's what it is, because the other thing that I've seen happen before too is you just have to be careful that sometimes you'll get to clicking around and you'll get outside of the box, and then it won't see it as being in that particular area. But that's what it is. I about guarantee it. Okay. Yeah, if it's a laptop, that's more than likely your issue.
Yeah.
So try that. Try using the function and see if that'll do it.
Thank you so much.
Like I said, good catch, Nick. I tell you what's really wild. I've worked with World Skills, which is kind of like Skills USA, but at the world level. Wait till you see like Hungarian keyboards, and I mean we had keyboards from all over the world, and it's just you just don't even think about how different the layouts are on those keyboards. I am going to go ahead and end this reservation, that way I'm not using a pod for somebody's way. Okay. Any other questions on our Cyberops class so far? Any issues, anything causing problems? I'll turn the video back on now because we're good. If y'all have any questions, if you do have any questions, let me know. Drop them in chat. We're going to blow through 5 through 11 pretty quickly, especially 5 through 10 very quickly, because this is, again, the section that you can more than likely just really skip through fast if your students have had CCNA 1 or Networking Essentials. If they have not, you need to spend time in this, because one of the most important things for you to realize is that as they get further into this course, they've got to understand MAC addresses. So real quick, what is a MAC address? Anybody tell me what it is?
MAC address and physical address is the same, I believe.
Exactly. So it's the physical address that is burned into the NIC. Well, the device. I mean, we can say NIC, but it could also be burned into a built-in network interface card or built-in interface card, or it can even be burned into the actual board on like a switch on the backplane. But it's the physical address. Remember, it's 48 bits. Okay. What are the first 24 bits? Anybody remember what the first 24 bits are? Yeah, remember that first part, what we call that?
I forgot it.
Aren't they assigned to the manufacturer or something like that?
They are assigned to the manufacturer, and just remember French we. It's really not we, it's OUI, but it's the organizational unique identifier, which if you've never heard the story, that's how they caught the bind, torture, kill serial killer, because when he sent his manifesto in, he had made it on a computer that he had bought, and it had the MAC address associated with the Word document, and they tracked it back to where he bought the computer and thought he was the guy anyway, and that pretty much confirmed it. So kind of a wild story there. But 24-bit organizational unique identifier, which is from the manufacturer, and then the other 24 bits is the actual serial number of the NIC. So serial number. Now, these are supposed to be globally unique, and as you know, one of the things that the student has to understand before we get into tracking down network attacks and understanding network attacks is the ARP process. And ARP and Ethernet and how they are all related are part of these sections here, this section here. Now you'll notice I'm just going to really blow through this and not even spend any time on this section, because this goes through what the TCP/IP protocol suite is. By the way, where did this come from right here? You'll see a lot of this. This very image is in Cisco 1. This is in Cisco 1, or something very, very close to it is in Cisco 1. So be aware of most of this is reused content. I know this is from Cisco 1 because that's in one of the very first chapters in Introduction to Networks. So they've reused some content here. But your students, if they've got that background, you'll be able to go through this very quickly. I would still review it unless your students are really good at this, but you can kind of blow through this fairly fast. It goes over the OSI model and the TCP/IP model, how they interrelate with one another. So it's a good way to reinforce what your students learned in your other courses. Okay. Now, data encapsulation. This is where we kind of start getting into the meat and bones of meat and potatoes of what we want to do here, and that is looking at how we encapsulate data and de-encapsulate data. And then we're going to go even further, because we're going to look at Ethernet and how Ethernet uses this encapsulation. So right down here on Ethernet, okay, so we look at the OSI model, we look at how Ethernet is a layer 1, layer 2 standard, And our 8022 is the logical link control, and 8023 handles the physical and MAC. So, and remember, the MAC or media access control is dealing with physical addresses, or MAC addresses. The logical link control, or LLC, is that barrier between what we consider hardware and what we consider software. So the MAC address is technically something we could touch. We can touch the NIC. The logical link control is that boundary between layer 2 and our layer 3 protocol. So whether it's IPv4, IPv6, IPX, SPX, whatever, the good old days when we had multiple layer 3 protocol types. Here's our different frame fields inside of Ethernet. And it's important we talk about, our students understand that in Ethernet, in order to communicate, to build a frame, you must know your source MAC address and your destination MAC address. And that is dependent upon our ARP protocol, ARP process. So what happens if a client tries to send out a message but doesn't know the MAC address of the destination? It knows the IP address but doesn't know the MAC address. What will that client do? Anybody remember? Remember, they'll send out an ARP request. So it sends out a request and says, who has this IP? And I'm paraphrasing. It's not exactly what it says, but it's pretty close. Who has this IP? What's your MAC address?
Oh, you were talking about if the MAC address wasn't in the MAC table.
Correct. Yes. If it's not
Okay.
in the MAC address table, that is correct.
Okay, yeah, because I got all confused when you were saying it knew the IP. I was thinking, well, then it's got the IP in the MAC table. But
Well,
okay,
yeah, you could have the IP address, but not have the MAC address in the MAC address table.
okay,
Correct.
I got you. I got you.
All right.
Cool.
Now, let me ask you this. I'm gonna give you two. An ARP request goes out to a local host. Who responds? So an ARP request goes out to an IP address that is on the local segment. Who's going to respond to that?
Whoever has the MAC address.
Correct. Yeah. The host with that IP responds with its MAC address.
Yeah, I'm sorry. Yeah.
Okay. Now the problem with that is a lot of times, many times, in fact, we're not trying to find the MAC address of a local host. We're trying to find the MAC address of a remote host. So when that ARP request goes out, who responds?
Well, it goes through the default gateway and then it bounces through routing tables until it gets to wherever it needs to go.
Well, not the ARP request. The ARP request
Oh.
does not. What happens is, remember our concept of proxy ARP? So if
Oh,
it-
yeah. I'm
if an
sorry.
ARP request goes to a remote host, layer 2 doesn't get passed through a router, but the router will proxy its MAC address with, so the default gateway basically proxies its MAC for the remote. So really every remote host that your PC goes to, the MAC address that's assigned to that is actually your local gateway, your default gateway. This is super important for security because what if I can spoof the responses and make you think that the MAC address of my machine is the default gateway? Then you will send your information to my machine and then I will do a man-in-the-middle attack. So that's one of the reasons why we need our students to understand how an Ethernet frame works and how the ARP function works. So it goes all the way back through showing you MAC addresses and how they can be represented with dashes, colons, periods. But just remember, the first 24 bits here would be the OUI. The last portion would be the serial number. So we actually have OUI lookup. So we look up Wireshark OUI tool. So let's just put in here the 00602F. So 00:602F. Let's see if that actually matches anything. Yep, Cisco systems. So they used in their example the OUI that is partly assigned to Cisco. Now I'm sure Cisco's got more than just this one OUI associated with it, because most large manufacturers have more than one. So if you go down here and look, let's do a Control F just for save us time. That didn't work the way I wanted it to. There it is. Cisco systems, they got 000142 and 000164. So you can see there's multiples. And that's because even at 24 bits, there's not enough addresses there for all the different pieces of equipment that Cisco has put out over the years. All right. Now, the rest of this is just a basic review of IP, best effort, how IP encapsulation works, characteristics, connectionless. It's a best effort delivery, media independent. This, by the way, is the reason why we're all using IP v4 and v6 instead of some other protocol, because they didn't care whether it went across copper, Ethernet, serial, fiber, carrier pigeon. It did not matter. As long as it held to the MAC LLC and the layer 3 standards, didn't care, could run it on anything. There's even a section in here that goes back over what subnet masks are and what IP addresses are in terms of host, network, and host portions. This again is straight out of CCNA 1 or Networking Essentials. So I feel this part, I don't need to spend time with you on it. You need to make the decision for your students how much time you need to spend on these sections. I would probably suggest a good amount of time even on IPv6, just because going back over this, because even though we do this in CCNA pretty in depth now, students still need more work with IPv6 simply because we don't spend a lot of time with it. Okay. All right. The other item here, ICMP, this is a very short section. I don't spend much time on it just because ICMP is, this you could see somewhere. By the way, remember, one of the things that we need to do, I think I've got it in here. Yep. We need to make sure as you're going through preparing your students for the exam that you're looking at the different exam objectives. Okay, so we're looking down here at different parts of what it is. Trying to see if there's really, this part right here, we're getting ready to do a little bit on with IPS. But a lot of this, they've got to understand these concepts in order to do it. So it's not necessarily going straight through networking, but they need to look at those concepts. So this, they may need to know that net unreachable, host unreachable, protocol unreachable, and port unreachable are some of the codes for ICMP version 4. Every time, true false, every time an ICMP packet goes through a router, the TTL is decremented by 1.
True.
True. Yeah, that's true. What happens when the TTL is exceeded?
The packet gets dropped.
It gets dropped. Yeah, it gets dropped, and typically a destination unreachable or some type of time exceeded message gets sent back. Well, typically it's a time exceeded message, not destination unreachable. Okay. These router solicitation, router advertisements, we talked a lot about these. These are used in our multiple methods for providing addresses to a IPv6 host. Remember, we got Slack. We've got Slack with stateless DHCP and Slack, or actually stateful DHCP. So those are the 3 different ways you can do it: stateless address auto configuration, stateless address auto configuration with stateless DHCP, or full stateful DHCP in IPv6. All of those pretty much take and use router solicitation and router advertisement messages. It's also the method used by ICMP to do DAD or duplicate address detection to ensure that they aren't giving themselves an already existing IP address on the network. They've got a couple things here. I would stress to my students in the real world, ping and traceroute both can have very limited usability because of the fact that we block ICMP on so many networks now. So internally, yeah, they've got a lot of use and they're very good. Externally to your network, hit or miss, because like I said, most networks today block ICMP on the outside and do not allow for any type of tracing into a network or out of a network. So it has pretty limited usability in that respect. So here's MAC and IPs. And this is where I was talking about destination on the same network. The host is just going to respond with its MAC address when an ARP request goes out. We can build our layer 2 header. Now, one of the reasons why this is a historical thing that's kind of neat to look at, but one of the reasons why Ethernet has the destination MAC first and the source MAC second is because on old networks that were actually bus networks, every single host that saw a frame had to bring it up and look at it at least to layer 2 to see the destination MAC. And if it wasn't its MAC address, it would then discard it. So putting the destination MAC first meant you didn't have to read 48 bits that you didn't need to read that you're going to throw away a frame for anyway. So that's kind of a neat little historical fact. If it's on a remote network, well, the router does a proxy ARP and responds with its MAC address as the destination MAC address. And remember, every hop, the layer 2 information is rewritten based upon the link between the routers. Layer 3 information will only be rewritten if you're using NAT or PAC, but layer 2 information is rewritten at every single hop. So when you think about it, it's honestly kind of amazing how quickly communication takes place on the internet. When you think about how it's got to be rewritten, it's got to be taken apart, looked at, routed. Now, of course, we do have CEF, Cisco Express Forwarding. We've got the building of information table or forward information tables inside very high-speed memory, but it's still really interesting to see how quickly things can actually go from one computer to another over the internet. So here's ARP. I have this IP, but only have but I don't know the MAC address, and we'll send out an ARP request and get an ARP reply. And of course, they got a little video here. Wow. Okay, sorry. All F's is obviously a broadcast, and that's how ARP works. So it goes through, and I'm not going to watch the video with you, but that's basically how it works. And the ARP reply will be there. The important thing to note is that the ARP table, depending on the operating system, if it's a Windows operating system, if you do an ARP resolution, it will stay in the ARP table for up to 2 minutes unless you use it again within that 2 minutes. And if you do it, I think it stays 10 minutes, and then it will be refreshed. So there is a way for it to be removed from the ARP cache. On Cisco routers, the ARP cache access got a 4-hour limit on it, 4-hour time limit by default, I believe, on most Cisco routers. So be aware of that. Does anybody know the normal timeout of the ARP cache table on Linux? Anybody know off the top of their head? We can always ask the Holy Google. So it's 15 to 45 seconds. Three 3,000 milliseconds. Okay, that's not useful. It's 2 minutes also. Okay. So like I said, I know in Windows, if it's used again within that first 2 minutes, it stays in there 20 minutes and then it's flushed. And you have to do another ARP request. All right. Some issues, broadcast and spoofing. ARP is broadcast. And so as a result, a nefarious hacker can try to spoof to be the MAC address of the default gateway. And what they would usually try to do is do a denial of service attack on R1 so it cannot respond, and then start forwarding traffic that comes to it to the default gateway. So it'll become a man in the middle. How do you stop MAC address spoofing? What tool have we learned in CCNA that will stop MAC address spoofing? Anybody remember? Uzma?
I forgot. I'm trying to remember.
Remember how we could set it to max addresses to switch port security. Remember we did switch port security, turned on port security, and we do switch port,
Yes,
Switch
switch
port,
port
port
security. Yes.
and then we would do, you know, maximum addresses, max addresses, and give it a number and whatever number you want it to be.
Yes.
You had to be real careful not to just make this one. Then you also could do, remember, switch port security violation mode, shut down, restrict, and protect, the 3 different modes that are available. So with port security, if you make port security turn it on, when the hacker would try to put their machine onto a port, then it could cause the port to be shut down. The other thing that we do, it's simply this: if this nefarious hacker C here couldn't plug into a port because this port is shut down, it's not in use, and they try to plug their laptop in, well, that's another thing, to shut down unused ports. Shut down unused ports and use port security. That's the 2 ways that we can mitigate ARP spoofing or MAC address spoofing. Okay. Any questions on ARP? You understand why it's so important for your students to know this. It's also very important for them to know moving up. Okay, so we've looked at layer 2, we've looked at layer 3, now we're at layer 4. They need to understand how TCP works, how sockets work, how you have a source IP and a source port, a destination IP and a destination port, how the difference between TCP and UDP, and how TCP is connection oriented and UDP is connectionless, how TCP does guaranteed reliable delivery through the use of segmentation, windowing, sequencing, all those things that are used by TCP. The 3-way handshake of TCP, which can actually be used against your systems. It's not as much anymore because we've got so many mitigation techniques for SYN floods. But the fact that in the older days that SYN floods were a true worry for our devices. And UDP, being its unreliable little brother of layer 4, is just connectionless and best effort delivery. So very important for them to see all this and understand. I like to do this too. I really do like to show the 2 header fields, because people, it's very clear to people when they say, okay, look at this header here. Now compare this header and all of its complexity to the header from UDP, and you go, well, yeah, UDP is much simpler. There's a lot less going on in the header for UDP. So it's much faster and much more efficient. Just it's not reliable. But that doesn't matter if you're streaming video or if you're streaming audio. And there's certain places where reliability is not as important as speed. Or you can make reliability a function of the upper layer protocols, not necessarily your lower layer protocols. Here again, showing a full socket, destination MAC, source IP, destination IP, source port, destination port. Your students must, as we move forward into the more detailed look at connections between devices, your students must understand how this works, how that when a source sends it out, that this source port is where it's coming from, the destination port is the service that it's going to on the other device, and understand this complete connection so they can understand how that can be manipulated in order to do nefarious things. Okay. We've got a lot of videos on TCP that you can watch, that you have your students watch. They're all pretty good. Most of them are just going back over the very concepts we've had. Again, windowing, flow control, those types of things. How many, the window size, remember the sliding window concept? What was meant by the sliding window concept? Anybody remember? Were any of you around when Windows 95 first came out and it had terrible performance on the internet? And the reason they found out was, you remember that, Jer?
Oh, yeah.
What
Yeah, I
was the
remember.
what was the solution? You remember that? The actual problem was the
Not so much
initial-
because I was on dial-up back then, didn't pay
Yeah.
attention.
Well, the big problem was the initial window size was too small in the TCP/IP stack. So you just go into the registry in Windows and make that window size bigger, because a sliding window is, it will try a certain size window and see if it can get all the segments sent and acknowledged. If it can't, if it's losing segments, it will slowly slide the window down to a smaller size. And once it gets where it's reliable, it'll start then trying to make the window bigger. So the window is sliding. So the size of that window can be different based upon the conditions of the link, which was very important back then because we had terrible dial-up links. So you could very well have bad performance. Today, with our all digital, well, predominantly all digital systems, things are much more reliable than they used to be. So pretty cool idea there. Nothing super important. This I do like is a review of all the services we talked about in really almost the last 2 or 3 chapters of CCNA 3. So DHCP, Dynamic Host Configuration Protocol, and the 4 steps, which is good old Aunt Dora: discover, offer, request, acknowledgement. Remember, I always say good old Aunt Dora, D-O-R-A, discover, offer, request, acknowledgement. You send out a DHCP, hey, are there any DHCP servers out there? That's the client. The server says, yep, I'm here. Here's an IP address you can have. The client says, that's a mighty fine looking IP address you got. You mind if I use it? And then the server will send its acknowledgement. Along with this will be options such as gateway, DNS. It used to be Win server way back in the day. We don't do that anymore. But now you may get things like TFTP server, which will be used by your IP phones booting up to find the configuration files they need, and other assorted items that can be placed into those options. So here is a message format. I don't know why they got quite this detailed with the message format on DHCP, but it's here. So I don't think you need to know it that well, but this is one I would spend some time with because we kind of go over it in CCNA, but we don't talk about how actually dangerous this is. If I type in www.bankofamerica.com, I expect to go to bankofamerica.com. The worst possible thing is for someone to be able to mess with DNS and send me to a site that looks just like bankofamerica.com, but is not bankofamerica.com. So that is really something that we've had to work on, and that is secure DNS and trying our best to get the DNS process secured more. That's why many people on their own personal PCs use Google's DNS. And that's the only problem with that is, of course, that's what they're trying to hit too. But this idea of a root domain, which is .top level domains made up of all of these, and then your second level domains, and then the actual servers, which are part of that second level domain. This is how you can explain the fact that DNS uses both TCP and UDP. UDP is these DNS queries between a client and a server, and then many of the queries between servers or transfer of DNS information between servers is using TCP, so that it is guaranteed and reliable. So interesting there. Notice the A records for IPv4, quad A is for IPv6. Mail exchange records. One of the things that you do need to learn, and this is real world, is if you ever have to play, well, I won't say play because we don't play with DNS records, but if you ever have to change a DNS record, it can take some time for MX records and other records to propagate throughout the DNS system. So sometimes you have to be really careful, especially when you start changing MX records and pointers and those types of things. inside your records to give it time to be able to propagate. Questions about DNS? Any questions about dynamic DNS? Any of you using dynamic DNS at your home? Dynamic DNS is if you don't, say you have a DHCP address at your house and you still want to be able to get into your systems, you can have a dynamic DNS. And what it actually does is it goes and it just keeps checking your system to see if the IP address has changed. And then it will provide you with a DNS record that will still go to your site. And if it changes, it can actually change itself automatically. So everybody knows RFC 1918 addresses. You know, you're at a dinner party, somebody asks you, you need to know those. You walk up and say, hey, do you know RFC 1918 addresses? Oh yeah, that's the private IP address range for IPv4. NAT is translating between, here's something we typically say. We typically say that NAT is from private to public. It's not always true. NAT is simply anytime you're translating between two sets of addresses. You could technically go from public to public. We just don't do it very often. 99% of the time we do from private addresses in the RFC 1918 range to public addresses that are on the public addressable range. So anything that's not in RFC 1918. Everyone knows the APIPA addresses, right? I think I've talked to y'all about these already. APIPA, automatic private IP addresses. What range is this? Remember, so 169.254.0. I can't type. 169.254.0.0/16. It's at a range of addresses that Microsoft uses for whenever a Windows box cannot find an IP address at a DHCP server. It's same thing with their Xbox. Xbox will do the same if it boots up and can't find a DHCP server. So it gives you a private set of addresses that can be used in the event there's no DHCP server around. And the only real difference between NAT and PAT is NAT can be a pool of addresses, whereas PAT we're actually translating, or we're using NAT and we're translating to the IP address that's assigned to an outside interface already. So we're sharing the IP address of a physical interface with PAT. NAT may be a pool of addresses that you have available instead of just a single address that's on the outside. At our homes, 99.9% of us are using PAT. And then I really don't need to talk much about SNM or TFTP, FTP, SMB, server message block. You know, Samba on a Linux box, but it's basically how Windows used to share most of its stuff, and there's still some components of that available in Windows. I'm actually not as familiar now with how Windows is doing its file sharing as I used to be. I do know there's some backwards compatibility with SMB still in there, but now instead of using a lot of the old processes, it uses DNS as the basis for being able to find structures inside of Active Directory. Anybody know if anybody in here a Windows expert? If you are, tell me how SMB is still used inside of the Windows world now, especially all the way up in Server 2016 and further. Nobody a Windows expert? It's a good, actually, here's a good question. In your area, are the majority of companies using Windows and Active Directory, or are they using something else?
Active Directory.
Jared's Active Directory. Okay.
Yep.
Usma, how about you?
Sorry.
Are the companies in your area, are they using Windows operating systems, or are they more likely to be using Linux for their
Windows
servers?
system.
Do what?
Windows.
Windows. Okay. Nick, I know you're traveling, so we'll give you a pass. How about Debu?
Hey.
Oh, Nick, go ahead. Okay.
I was gonna say most of the people I know are doing Active Directory, but they're doing it in the Azure cloud. So
Okay, so run on Azure Cloud. Are any of them running Windows boxes on ESXi infrastructures, on VMware infrastructures?
Definitely.
Okay. Debu, what about your area?
I will use Active Directory Windows.
Okay, that's very common. I will tell you this, again, going back to my world skills experience, I found out very quickly that in the Eastern countries, Far East, Linux. Europe, a lot of Linux. Also, if you find anybody that's working in the ISP space or the large service provider space, large amount of Linux. But your students are probably like mine. They're going to more mid-sized businesses. And those mid-sized businesses typically are Windows businesses or use Windows servers on Azure.
If you're going to work for Google, you better know Linux.
Yeah, you better know it, and you better know it well. Google or like Amazon or any of those, because all of their stuff is really kind of run on that Linux infrastructure. Okay, so I'm not going to spend much time on HTTP and all that, but just this is here, and it just goes over the basics of how this works, what a URL is, some of the get, post, put, delete. This is good to know because it also helps you when you start looking at REST and RESTful APIs and those types of things when we get into any type of DevOps down the road. And even these codes are very important once we get into DevOps because it can help you troubleshoot errors when you're trying to do requests through an API. All right. And folks, like I said, that is really sections 5 through 10. There's not a great deal in here that is anything that should have been super new for you. Are there any questions about these different chapters, sections, modules? I cut the modules now, but modules 5 through 10, any questions on those? I think it's pretty self-explanatory. Okay, well, I will end with that, folks. I'm going to stop the share. I'm going to stop the recording.